Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to go through question number 3 from chapter 31 of the student assessment exercise 3. This is from the vectors chapter of the Cambridge IGCSE Corner Extended 4th edition, from Pimental and Wall. And this is a Hodder book, and this question here is, as we can see, about vectors. And let me just get rid of this for now. It says the parallelogram ABCD. So we have a parallelogram, shows the points P and Q, dividing each of the lines AD and DC in the ratio 1 to 4. In the ratio 1 to 4. So when you have a line dividing another line in that ratio, so let's just consider DC because it's horizontal. All right, so say this is D and this is C, and this point Q here is dividing this line in the ratio 1 to 4. Okay, so that means the ratio of AD, the ratio of DQ, if Q divides the ratio of the line DC in the ratio 1 to 4, that means the ratio of DQ to QC is 1 to 4. Point Q divides it in that ratio, so that's one part, that's 4 parts. So in total the whole line is made up of 5 parts. Just like if I said, for example, there are 30 sweets divided in the ratio 1 to 4, that means you got 5 parts altogether, and the first part of the ratio is going to be 1 part of the 5, and the second part of the ratio will be 4 parts out of that 5. So similarly with lines, if it says in the ratio 1 to 4, okay, DC is divided in the ratio 1 to 4 by the point P. That means DQ is 1 part and QC is 4 parts. That's what we can understand from this. All right, so that's something important for us to understand, and that's going to come back towards the end of the questions, a little twist there that we'll see. Anyway, it says here, if dA equals the vector A, so from D to A, all the way from D to A, all of this is the vector A, and D to C is the vector B, so from D to C all the way from there to there is the vector B. Express the following in terms of A and B. So let's start with A part 1. It says A to C. A to C, so we're going to go from here to there. Okay, so we can go from A to C by going from A to D, and then from D to C. So we have A to D plus D to C. So that's going to be, well, from A to D is the same length as A, the same direction as A in terms of it's parallel to A, but it's in the opposite direction. A is going from D to A, and what we want to go is from A to D, so it's going to be minus A. Parallel vectors can be expressed in terms of each other, as long as they're parallel. They can't be just the same length, they must be parallel. If they're parallel but in opposite directions, then they are negative of each other. And D to C, as we can see here, is just the vector B. So we have minus A plus B. That's the answer, A part 1. A part 2, it says the vector from C to B. Now C to B is this vector over here. Now as we have a parallelogram, C to B and D to A are the same. They're the same vector. Okay, because they are parallel, the same length. Okay, so they can be expressed as the same vector, which is D to A, which is the vector A. So that's pretty simple. And then part 3 says the vector D to B. D to B. Now I can go from D to B in 2 ways. I can say D to C plus C to B, and that's going to give me B plus A. Okay, we already know D to C, we already know C to B, B plus A. Or we could say D to A if we wanted to. We could say D to A plus A to B. That'll be A plus, and now as we can say, as before, AB is parallel to DC. It's the same length as DC, so it's the same vector as DC, so it's going to be the vector B. So you have A plus B, which is the same as B plus A. So whichever way you look at it, you can write this as A plus B as well. That's perfectly fine. Alright, so there's the answer to part A. That wasn't a problem, I don't think, for the person. The person was asking about part B. So that's what we're going to get into now. Okay, so part B. So now let's just have this diagram here and try and sort out what we're going to do. So it says find the ratio in which R divides DB. Find the ratio in which R divides DB. Okay, and also it says for part 2, find the ratio in which R divides PQ. So first of all, let's take D to B. Okay, D to B. D to B, as we said, is the vector A plus B, or B plus A. We know that from our previous answers. And let's take the vector from D to R. D to R is a fraction of D to B. It's the same direction as D to B, it's along the same line as it, but it's not the same length of it. So it can be expressed as a multiple of D to B. If two vectors are in the same direction, but they're different lengths, then they are multiples of each other. So let's call that multiple K. So let's say that D to R is equal to some fraction, let's call that K, times D to B. Okay, so that's one thing out of the way for D to B, D to R. So I've got something which with dr and b in it, because I'm going to have to deal with those r, d, and b. I'm going to do the same thing now for pq. Now p to q, we haven't got the answer previously, but we can find it quite easily because we know these ratios. I know that p to d, it's not all of a, it's part of a. In fact, it's 4 parts out of 5 of a in terms of its length, and it's in the opposite direction. So we can say p to q is equal to p to d plus d to q. So p to d, as I just mentioned, is minus 4/5 of a. Okay, and d to q, well, that's 1 part out of 5 of d to c, so 1 part out of 5 of the vector b. So that's going to be 1/5 of the vector b. So we have p to q, and because we want to find how r divides p, this line between p and q, I'm going to also write down what p to r is. I'm going to work out what p to r is. Now p to r, I'm going to call it some multiple of p to q. We've already used k, so I'll use another letter. Let me use l. It's going to be l times p to q. Alright, so now if I can find the value of k, and if I can find the value of l, I will have now I will be able to answer this question. Okay, because then I'll work out what fraction dr is of db, and I'll work out what fraction pr is of pq. Okay, so that's what I'm going to try to do now. So the way to deal with these type of questions is to try to find the same start and the same end point. So I'm going to choose p to r, okay, but going through different routes, if you can understand what I mean. So I'm going to think of how to get from p to r in 2 different ways. I'll go directly, which is L times p to q, okay, which will be equal to L times minus 4/5 a plus 1/5 b. That's one way of getting p to r. That's one way of getting to p to r. And the second route to get from p to r, okay, would be just doing k times, okay, p to r, sorry, this would be, yeah, this would be k times, sorry, no, p to r, p to r, we're all around there, sorry, L times, okay, L times, p to r is L times p to q. Okay, I already got that way, sorry. I can say p to r is p to d, sorry about that, p to d plus d to r, sorry, yeah. So from p to d plus d to r. Okay, so that's another way we could get there. Now, p to d is going to be minus 4/5 a, minus 4/5 a, that's p to d. Let me get rid of this, sorry. Minus 4/5 of a, that's p to d. Okay, and d to r is basically, as we've written down here, it's some constant times d to b. Some constant times d to b. Okay, now what is d to b? It's a plus b. Okay, so it's some constant times a to b. So I can write this as minus 4/5 a plus k times a plus b. All right, now these two things must be the same as each other because they're both p to r. All right, so I can equate these two statements together. I can say L times minus 4/5 A plus 1/5 B is the same as minus 4/5 A plus K times A plus B, because they take us from P to R. They must be the same vector. If they're the same vector, then they will have the same A components and the same B components. So let's split these up and write them in terms of the A and B components. So for this one, we'll have minus 4/5 times LA plus 1/5 times LB. And here I'm going to have minus 4/5 A plus KA. And here I'll have plus B times K. So K times B, sorry. Put it that way better. K times B. Okay, so I have now the A components. If I compare the A components of both vectors, on this side, on the left side, I have minus 4/5 L. And if I compare the A components on this side, if I take out the A as common, I'll be left with minus 4/5. In fact, I'll write it like that just to make it clearer. Okay, just to make it clearer for those of you who might have a problem here. This is the vector on the left side. I've written them like separated A and B. And this one, I'm going to take out minus 4/5 plus K. Okay, and that's times A plus K times B. All right, so now I'm going to look at the A components. The A components are basically this and this, so they must be the same. And the B components are this and this, and they must be the same. Okay, so if I compare them, I can say minus 4/5 L must be the same as minus 4/5 plus K. All right, and from here I can say 1/5 of L must be the same as K. Okay, this is comparing the A components. This is comparing the B components. Okay, so now I have these two which I can kind of solve simultaneously. If I know K is 1/5 L, I can replace this K with 1/5 L. So I'll have minus 4/5 L equals minus 4/5 plus 1/5 L. And if I rearrange this, if I add 4/5 to both sides, and I add 4/5 L to both sides, I have 1/5 L plus 4/5 L, which is 1 L. So I have L equals 4/5. So I have L equals 4/5. And if L equals 4/5, then K is 1/5 times L, which is 4/5, which is 4/25. So I have K equals 4/25. So now I can take this little statements, or these statements I made up here, and whoops, what did I do there? I want to take these statements here. Let me just fix this. Sorry about that. Fix this in place. Okay, that's better. Now, if I take this and copy it and paste it down here so I can see what I'm doing. Okay, now, so we know that, well, in fact, I don't need this statement. I need this statement, and I also need this other statement about PR. I also need this statement here. Those are the two statements I need. That will help me. Okay. All right. So now, I know L is 4/5, so I can say that P to R is 4/5 of P to Q. That's how far along it is. It's 4/5 of P to Q. So PR is 4/5 of all of P to Q. And I can say that DR is K, which is 4/25 of D to B. Okay, so if we kind of rewrite this in a little way, I can rearrange this. I can say that means the ratio of P to R to P to Q is 4/5. And the ratio of D to R to D to B is 4/25. So we can write this as a ratio P to R to P to Q is equal to 4/5. and D to R to D to B is 4 to 25. Now, the problem in this question is, well, not in the question, in the answer to the question, okay, they've given the answer to this question saying that the ratio which R divides D to B is, and they've written it as 4 to 25. But I don't agree with that. All right, the ratio of dr to db is 4 to 25, but that's not the ratio in which R divides D to B. Okay, so the question that actually needs to be asked, if this is the answer, is find the ratio of D to R to D to B. Okay, and for this one, the ratio of P to R to P to Q. Then the answers would be 4 to 25, and for P to Q it would be 1 to, it would be 4 to 5. Okay, that would be 4 to 5. 4 parts to 5, and that would be 4 to 25. Okay, so that's where there's something, I think, a bit off in the answer. Okay, if you want to actually answer this question, you got to think about it like this. Let's think we have, just imagine we have here P, and we have Q, and we have R. And I know that the ratio of P to R to P to Q, which is what we found, is 4 parts to the whole thing, 5 parts. Okay, so the R would be over here, by the way, not there. 4 parts to 5 parts. So that means the whole thing is 5, because P to Q represents the whole thing. The whole thing is 5, and this is 4 parts out of the 5. That's 1 part of the 5. So we can say the ratio in which R divides PQ should actually be 4 to 1. That should be the answer for for number 2. It should be 4 to 1. And the ratio in which R divides DB, okay, so you see the whole thing is 25 parts. This is 4 parts, and this is 21 parts. The whole thing is 25 parts because D to B is the whole thing. So the answer for part 1 should actually be 4 to 21, because the whole thing is 25 parts, and we got the ratio of dr to the whole thing. If it was dr to rb, okay, then it would be 4 to 20, you know, it would be 4 to 25, dr to db. But here it says find the ratio in which R divides db. So it divides it into 2 parts. One is 4, the other one is 21, the whole thing is 25. So I personally think that, you know, the answer is to a slightly different question. Find the ratio of dr to db and find the ratio of pr to pq, then this would be correct. These would be the correct answers. But if it's find the ratio in which R divides these lines, then this is the first part. R is such that the first part from P to R is 4 parts, and from D to R is 4 parts, and from R to B is 21 parts. That makes 25 parts altogether. And R is such that PR is 4 parts out of 5, and RQ is 1 part. So the total is 5 parts. Okay, so that's exactly how we set up the question in the first place as well. Okay, so you know, when we did this, we said Q divides DC in the ratio 1 to 4. So we said there's 5 parts altogether. The first part is DQ, the second part is QC. That's how Q divides the whole line D to C, and that's how the P divides the whole line A to D. Okay, the ratio 1 to 4. So there's 5 parts altogether. Okay, so the whole line is mentioned. Same should be here. Okay, if we find the ratio of PR to PQ is 4 to 5, then PR to the whole line is 4 to 5, then R divides the whole line PQ in the ratio of 4 to 1. The whole thing is 5. Okay, so that's how I understand this question anyway. Maybe other people have another perspective on it, but I think the answer in the question in the end is actually an answer to a different question. The question, if you want those as your answers, should be find the ratio of dr to db and find the ratio of pr to pq. Then those would be the correct answer. If not, if you want to answer these particular question, then it should be 4 to 21 and 4 to 1. Okay, that's my perspective on this. If you disagree, please leave some comments in the comment section. Thank you for watching, and see you soon.